everyone! We're going to present on our project Biostatistics PBL or Problem-Based Learning. Our group members consist of Yuan Ting, Yongmin, Joey, and me, Xingyi. So now I pass the time to Yongmin, who will explain more to you about our project.
The research question is the mean total cholesterol level of adults in the 60s age group higher than the mean total cholesterol level of adults in the 30s age group? The independent variable is age group, which is the 30s and the 60s. Dependent variable is the total cholesterol. These are the summary statistics for the 30s age group and the 60s age group. The more important ones are mean, median, lower quartile, upper quartile, and the interquartile range. Take your time to read through them. From the histogram plotted, the distribution of the mean total cholesterol levels of adults in the 30s age group has a positive skewness, which is skewed right, and a normal kurtosis. On the other hand, the distribution of the mean total cholesterol levels of adults in the 60s age group has a negative skewness, which is skewed left, and a normal kurtosis.
Now I'm going to talk about the measures of central tendency. Some of the common measures include mean, median, and mode. So first of all, for the mean total cholesterol levels of adults in the 30s age group is 218.7, which is lower than that of the adults in the 60s age group, which is 255.2. The difference between the mean total cholesterols of adults in the 30s age group and the adults in the 60s age groups are 36.5. The next common measures is the median. The median total cholesterol levels for adults in the 30s age group is 210.5, while the median for the adults in the 60s age group is 260.5. This means the adults in the 60s age group has a higher median of 50 compared to the adults in the 30s age group. The last common measure of central tendency will be the mode. The mode total cholesterol level for adults in the 30s age group is 206, which is lower than the mode in the 60s age group, which is 254, and the difference between them is 48. Next, I'm going to talk about the measures of dispersion. Some of the common measures of dispersion include the range, the interquartile range, or what we call IQR, your standard deviation, your variance, and coefficient of variation, which is your CV for short. So first of all, adults in the 30s age group has a smaller range of mean total cholesterol compared to the adults in the 60s age group of 13. This goes the same for the IQR, with 48.5 in adults of 30s age group and 49.3 of 60s age group, which means that the 60s age group has a much higher IQR of 0.8 compared to the adults in the 30s age group. Next type of measure of dispersion will be your standard deviation. Adults in 30s age group has a standard deviation of 41.7, which is lower than compared to the adults in the 60s age group of 1.7. This indicates that the mean total cholesterol levels of adults in the 30s age group has a smaller deviation from the mean and a smaller spread of data. Next type of measures of dispersion will be your CV. The CV for adults in the 30s age group is higher than that of adults in the 60 age group of 0.021. This also indicates that the mean total cholesterol level of 30s age group has a larger spread compared to the adults in the 60s age group. From the 5-number summary, which is the highest value, the lowest value, the upper quartile, lower quartile, and medium, we are able to plot the box plots. From this diagram, you can see the box plots of the 30s age group and the 60s age group. So from the box plot, we can infer that the adults in the 60s age group has a wider range of mean of 13 compared to the adults in the 30s age group. Also from the diagram, we can see that the adults in the 60s age group has a higher median for cholesterol levels compared to the adults in the 30s age group. Furthermore, we calculated the outlier limit, and for the adults in the 30s age group, it has an upper outlier limit as the maximum value is 326, which exceeds the upper outlier limit of 312.8. And on the other hand, for the adults in the 60s age group, it has a lower outlier limit as the minimum value 128 falls below the lower outlier limit of 160.9. So from there, we can actually conclude that the adults in the 60s age group has a higher mean total cholesterol levels compared to the adults in the 30s age group.
Therefore, we have come up with the hypothesis testing, and mu1 will be the mean total cholesterol of the people in the age group 60s, and mu2 will be the mean total cholesterol of the people in the age group 30s. The null hypothesis is mu1 minus mu2 equals 0, and the alternate hypothesis is mu1 minus mu2 is more than 0. The type 1 error we have come up is when we conclude that the total cholesterol level of the people in the age group 60 has a higher cholesterol level, but in fact it does not. So type 2 error, on the other hand, will be when we conclude that the total cholesterol of the people in the age group 60s does not have a higher cholesterol than the people in the age group 30s, when in fact it does. The level of significance we have chose is 5%, and our data is normally distributed as the sample size is greater than 30. We can carry out the parametric test to find out the descriptive statistics. So the sigma square 1 will be the variance of the total cholesterol of the people in the age group 60s, and sigma square 2 will be the variance of the total cholesterol of the people in the age group 30s. The null hypothesis is sigma square 1 is equal to sigma square 2, and alternate hypothesis is sigma square 1 is not equal to sigma square 2. The type of test is two-tailed test and F-test. Okay, first we'll go to stat, then basic statistics, and two variances to check whether the variances are equal. And we'll do samples in different columns, and first one will be the total cholesterol of the age group 60s, and second will be the total cholesterol of age group 30. Now we'll go option, and the confidence level will be 95%, and hypothesis ratio will be variance 1 over variance 2, and the alternative is not equal, and yeah, we'll click OK. So the test statistics we got is 1.08, and the p-value is 0.785. The 95% confidence interval is 0.641 and 1.906. Since the test statistics value is 1.08, which is greater than 1, we can conclude that the variances are unequal, so the standard deviations are also unequal. As I mentioned earlier, the null hypothesis will be mu1 minus mu2 equals 0, and the alternate hypothesis will be mu1 minus mu2 is more than 0. The type of test is right-tailed test, and two independent t-tests with population standard deviations unknown and unequal.
Next, we will go to basic statistics, 2 sample T. Then we will choose samples in different columns. The first one will be total cholesterol for age 60s, and the second one will be total cholesterol for age 30s. The confidence level is 95%, while the alternative is greater than. The level of significance is 5%, while the test statistics is 4.29, p-value is 0, and 95% confidence interval is 22.38. Since the p-value used is smaller than the level of significance, the null hypothesis is rejected. The test is said to be significant, and we can conclude that the total cholesterol of the people in the age group 60s have higher cholesterol values than people in the age group 30s. According to my group, the conclusion is valid as the age is one of those important risk factors that determine the amount of cholesterol in our blood. According to research, cholesterol levels do increase with age, as there will be lesser active receptors to remove LDL cholesterol. Our conclusion matches our observation in part 1 of the report. In this graph, the shaded area represents the rejection region, while the unshaded area represents the acceptance region. To compute power, we select statistics, power and sample size, 2 sample T. The sample size will be 50, while the differences used is 36.52, and the power value will be left blank. And standard deviation for our case, we use the average, which is 42.55. For alternate hypothesis, we use greater than since it is a right-tailed test. And significance level is 0.05. Our power is calculated to be 99.6%. The power of our test is very high, which is very good. This is because the probability of rejecting the null hypothesis when it is false is very high. Thus, we will be able to obtain a correct conclusion. According to our group, our desired power is 90% and higher. This is because the higher the power, the higher the probability of rejecting the null hypothesis when it is false. So we will be able to get the correct conclusion. To find the sample size using our desired power, we select statistics, power and sample size, 2 sample T. The sample size will be left blank, and the differences will be 36.52. The power value is 0.90, which is 90%. And the standard deviation is 42.55. Our alternate hypothesis is greater than since it is right-tailed, and significance level is 0.05. The sample size is calculated to be 24 for each group. Therefore, the total sample size will be 48. The total sample size that was given to us was 100, which was considered a large sample size. If we had the chance to request data all over again, we will not change the sample size. This is because the larger the sample size, the results are more reliable, and we can assume that the sample population is normal.
We have come to the end of our video. Thank you for watching.